12, we look at angles that are beyond 360 degrees, both in radians and degrees. And one of the things that's going to be super helpful when we look at a big angle is to be able to tell what is its reference angle and what quadrant it is in, so that we can use the cast rule. Because once you know the reference angle, you can do all the trigonometry like you did in grade 10 and 11. And once you know what quadrant it's in, you can use your cast rule to say if things are positive or negative. So what we're doing here is we're starting off with 4,300 degrees, and we want to find out what quadrant it's in. We're going to do it both with a calculator and without, and then find out what its reference or what angle it's coterminal with. So if you had a calculator, you could take 4,300 degrees and divide it by 360 and find out that it is 11.94 rotations, almost 12 full rotations. And the decimal part, because it's really close to 12, or between 0.75 and 1, because if you split your 4 quadrants up, this is a quarter away, this is halfway around, this is 3/4, that's all the way around. Does it make sense that having that 0.94 is telling us it's in quadrant 4? If I had this without a calculator, what you can do is you can subtract 360 degrees and you'll end up with something coterminal. Every time you subtract 360 degrees, you would end up with something coterminal. Personally, what I would start with is I would be like, mental math-wise, I think it's easy to subtract 360 degrees 10 times. Okay? That's going to leave me with 700 degrees. So 700 degrees is coterminal with 4,300. And if I get down to 700, it's not hard to subtract 360 degrees again. Underneath. 700 degrees minus 360 degrees is 340 degrees. So now I can say that 4,300 degrees is coterminal, ends in the same place, as 340 degrees. And if I did this without my calculator, I could also use this now to say, I know that 340 degrees is in quadrant 4. I also now know that my reference angle is 20 degrees. Because reference angle is how far that angle is from the nearest x-axis. So this is how I would do it in mental math. I think in the notes here, I showed that you could subtract 11 times. I did 10 times first and then one more. That helped me figure that out. So, figuring out where something is in degrees. Next, radians. And this is what we're going to do more often, is do questions in radians than in degrees. The nice thing about radians is, unlike degrees, like when you had that 4,300, you can't just look at it and say, oh, I know the reference angle is 20 degrees. However, in radians, you can tell a reference angle very easily, especially when it's written like this, 23 pi over 6. If you had to guess, do you think this is part of the pi over 3 family, pi over 4 family, or pi over 6 family? 23 pi over 6, okay, you have your guess in your head, is part of the pi over 6 family. So we can look at that angle right away and know that this is part of the pi over 6 family, which is powerful because that's on your pi plate. That's on your unit circle. You can now, once you have that unit circle memorized for tomorrow's quiz, you could say, oh, I know that sine of pi over 6 is 1/2. So sine of negative 23 pi over 6 will also be 1/2. I just have to determine if it's positive or negative. So you could, if you had a calculator, do the same thing that we did in degrees, but most of these questions are non-calculator, and you're required to find out which quadrant negative 23 pi over 6 is with mental math. And the following is how we're going to do it. We're going to start by changing negative 23 over 6 to a mixed fraction. Do you remember how to change from a whole improper fraction to a mixed fraction? Like, how many full 6s fit into 23? There would be 3 of them. That would get me to 18, leaving me with 5 more. So negative 23 over 6 is the same as negative 3 and 5/6. And this is what we're going to do with radians. We're going to think in fractions of pi. So here's our unit circle. You're starting at 0. All halfway around is pi. A quarter of the way is pi over 2. 3/4 is 3 pi over 2. And all the way around is 2 pi. And if you kept going more than once, we can start to count in terms of pi. So I'm going to just jump in halves. Halfway around is pi. All the way around is 2 pi. Does it make sense that if I kept going, this would be 3 pi? And all the way around twice would be 4 pi. Then another pi, this would be coterminal with 5 pi. And this, coterminal with 6 pi. Next, I would get 7 pi. Do you see a pattern? Or should I spend the next hour and a half to keep writing numbers? 8. And then over here, 9. Some of you are like, yes, I would enjoy watching you keep writing numbers. And then I ask, do you see a pattern? You go, no. How many more numbers will he write? But can okay. We can see that these ones are all even numbers, and these ones are odd numbers. So we are going to think in radians in fractions of pi. And we're going to do it this way. I have negative 3 and 5/6 pi. What quadrant is this in? Well, it's an angle in standard position. Standard position is going to start here. It's negative, so I'm going around in this direction. This would be negative 1 pi. All the way around would be negative 2 pi. The fact that I have an odd number, negative 3 and 5/6, the fact that the whole number is 3 is an odd number, that tells me right away I'm on my negative x-axis. That's what the negative 3 tells me. I now need to keep going and do another 5/6. Can you see that the 5/6 part is bigger than a half? So I need to go more than halfway. I will end in quadrant 1. This is powerful because if your calculator is now in radians and you type in sine of negative 23 pi over 6, your calculator will say positive 1/2 because it is coterminal with pi over 6. So we can see from the actual angle in radians right away what our reference angle is, right away what the family is. Hey, it's part of my pi over 6 family. Then the mixed fraction, and you're going to have to get really good at this, changing it to a mixed fraction and then determining where is it going to be. The whole number is going to tell you if you're either at your positive x-axis or negative x-axis. We had a 3. That puts us on the negative x-axis. The negative tells us which direction we're going. Positive angles go in one direction, negative angles go in the other direction. And then the 5/6, we just have to determine, is that bigger than a half or less than a half? Because we're at -3, which gets me to here, and then 5, 6 means I'm going more than a half, so then I'll be in quadrant 1. So in radians, it's going to be really easy to say what it's coterminal with. The first positive angle it's coterminal with is the pi/6 family in quadrant 1. That's really easy. That's just pi/6. I wouldn't do the work this way, but again, just like before, you can take any angle and keep adding 2 pi, and you get something that's coterminal. In degrees, we add and subtract 360 degrees. In radians, we add or subtract 2 pi. And this we have to get really, really good at. So, I have got a worksheet that we're going to do a little bit together. And the more that you practice early with your radians, the rest of this unit will go better and better. So, this is assignment. We are going to do a bit of assignment 1 together and a bit of assignment 2 together just to get you started. Assignment 1 says take every single angle you see in questions 1 to 32. After question 8, some of them have sine and cos. You can temporarily ignore that for assignment 1. You just, in assignment 1, think about the angles. Okay? And what I want you to do is find the first coterminal angle that's positive. So, what does this mean? Assignment number 1, question number 1, we have the angle of 13 pi/6. In your head, you already know the reference angle is pi/6. We need to figure out what quadrant this is in. If we use the technique that we were doing before, I can change 13 pi/6 to a mixed fraction. It will be 2 1/6 pi. Thinking in terms of pi. Here's 0, here's pi, here's the even ones, here's the odd ones. You would be starting here. You're going in the positive direction because you have a positive 2. Positive 2 would mean 1, 2. You would end at your positive x-axis. And then you want to go 1/6 more. 1/6 is less than a half, so you will stay in quadrant 1. So first, we know the reference angle is pi/6. We used our mixed fraction to tell us it's in quadrant 1. So we can say that 13 pi/6 is coterminal with pi/6. And that's what assignment 1 is looking at. So we'll do a couple, let's do a couple more, some bigger ones. Let's try number 5. 101 pi/4. First of all, right away, you should be able to tell that your reference angle is pi/4. Then, as a mixed fraction, this is 25 1/4. 25 is an odd number. That would take you to the negative x-axis. You're going in the positive direction because it's positive 25. So we're going to be going in this direction. Will we be going past the halfway point? No. 1/4 is less than half. So I know this is in quadrant 3. See how that logic works? Once I know pi over 4 family in quadrant 3, I can now say that 101 pi over 4 is coterminal with, what is my pi over 4 family in quadrant 3? 1 more than the denominator? 5 pi over 4. So your strategies for memorizing that I gave at the beginning of class can come in helpful here. Because you're going to have to be able to quickly say, what's my pi over 4 family in quadrant 3? Oh, it's 5 pi over 4. So I can say 101 pi over 4 is coterminal with 5 pi over 4. So that's assignment 1. You're going to do all the angles. You're going to think about what's the reference angle, what quadrant it's in, and then say what it's coterminal with. With the first, in the positive direction, the first thing it's coterminal with. Because any angle has infinite amount of things that it's coterminal with. We're just trying to find the first positive one. That is assignment 1. Assignment 2 says, for questions 1 to 8, find the coordinates. And for questions 8 or 9 to 32, just answer the question. So if we go to number 1, which we did, once we have found that 13 pi over 6 is part of your pi over 6 family in quadrant 1, you think about your unit circle quiz and say, for pi over 6 in quadrant 1, those are my coordinates. And one thing that I heard once for memorizing these is you have your unit circle, which if you draw out the whole unit circle, you can look at it and get answers from there quickly. But usually it's helpful if you have one of them really well memorized. And I would suggest sine of 30 degrees or sine of pi over 6. If you can remember that sine of pi over 6 is 1/2, then you'll be able to say cos of pi over 6 is root 3 over 2. And you'll also be able to say, well, if sine of pi over 6 is 1/2, that means cos of pi over 3 is 1/2. If you memorize one of them well, you can figure out the other ones quickly from that. So knowing that sine of pi over 6 was 1/2, I could write my y coordinate was 1/2 without having to look at my unit circle and get the memorized value from there. This takes practice. Okay, question number 5, if you wanted to find the coordinates for question number 5, well, 5 pi over 4, that's in quadrant 3. That would be negative root 2 over 2, negative root 2 over 2. And then if we do one of the questions, I'm going to do number 20, oh yes, number 26. Number 26, I'll do assignment 1 and assignment 2. We have cos of negative 13 pi over 6. So in assignment 1, negative 13 pi over 6, you would know that your reference angle is pi over 6. As a mixed fraction, it's negative 2 and 1/6 pi. So the negative 2 tells you that you're on your positive x-axis. The 1/6 is less than 1/2. You have to decide, okay, less than 1/2, is it in quadrant 1 or is it in quadrant 4? Well, because of the negative, you're going around in this direction. So it's going to be in quadrant 1. So we know that it is coterminal. What's your pi over 6 in quadrant 1? It's coterminal with pi over 6. So that's assignment 1. Then in assignment 2, it says, can you actually figure out cos of negative 3 pi over 6? Well, it's my x coordinate. I know, and here's where the memorization, if you know that sine of pi over 6 is 1/2, then you can figure out that cos of pi over 6 has to be the root 3 over 2. And it has to be positive because the cast rule says quadrant 1, everything is positive. So, we don't often get time to work in class unless I decide that something is really important that you get good at. And this is one of those things. So I'm going to give you some time to work on this assignment.